Hello everyone and welcome to Sine of Our Time. Today we are going to learn how to separate polynomials from non-polynomials. First, we need to look at how we define a polynomial expression. This is any expression that contains one or more terms of the form ax to the power of n, but there are certain rules that need to be adhered to. Now, let's keep this simple. A is an element of real numbers, which for now means that it can be any number you want it to be, including integers, rational numbers in the form of fractions or decimals, as well as irrational numbers. This means that our real focus should be on the exponent n, which has to be a whole number. Basically, this is the same as saying that n is an element of integers, but only from 0 upwards. It is important to remember that the terms of a polynomial can have more than one variable. That just means they can have more than one letter. For example, 2xy, negative 5ab squared c cubed, and negative 16 p to the power of 5 q cubed r squared s. All of these are still examples of polynomials. Okay, let's practice. All you have to do is decide whether each of the following is a polynomial or a non-polynomial, and I'll be sure to give you a few seconds to think about each. Remember that b squared can be written as 1b squared, which means it adheres to all of the rules, making it a polynomial. No, this one doesn't cut it because of the negative exponent. It is not a polynomial. Remember that if no exponent is shown, it is implied that the value of that exponent is 1. So this expression meets all of the requirements to be a polynomial. This is a polynomial. Remember, a can be whatever it is that you want it to be, including pi, so we have no problems here. Unfortunately, this one just doesn't cut it. This is because x is the denominator of the fraction. That just means it appears at the bottom. And this is not allowed, because if you take this fraction and you rewrite it in exponential form, we see that the exponent of x is negative 1. And that is a problem because the exponent must be a whole number greater than or equal to 0. And so this is not a polynomial. There is nothing to worry about here. It is okay for a term to have more than one variable as long as the exponents are all whole numbers. Here we have a polynomial. And remember, it is totally fine for the coefficients of the variables to be irrational numbers, like root 2 and root 3. No, just no. The second term is fine, but the first term has variables that have fractions for exponents. That's a big no-no. This one is a non-polynomial. Mind blown. This is still a polynomial. And you might be thinking, why? How? Well, 10 can be written as 10x to the power of 0 because x to the power of 0 is equal to 1, giving this an exponent of 0, which is allowed, making it a polynomial. No. we can never have the variables under square root signs, because if we change to exponential form, we have x to the power of a half and y to the power of a half. Those are fractions, and fractions are not allowed, which makes this a non-polynomial. I hope this gives you more confidence in separating polynomials from non-polynomials. Well, that's all from me, and I want to say a very big thank you for watching.